Right, can you all hear me? I presume you can. Any form of feedback? Brilliant. Someone said yes, I'm going to go. Right, so we are doing defining an acid. So as you probably know already, it's all to do with protons. And our proton is what actually defines an acid. So we need to know the difference between acids and bases. So traditionally, if we have HCl, we can write it as H plus and we have Cl minus. But what's actually happened, if we have HCl and we mix it with water, we get our chloride ion and we get H3O plus. And that's an oxonium ion, and we need to know that word. Right. So we've got H3O plus, which is oxonium. This is a proton donor. So that is our acid. Because it's a proton donor, that is our acid. This is our proton acceptor. Because that is a proton acceptor, that is our base. So that's the only difference between an acid and a base. The acid is always the H plus donor, whereas the base is always the H plus acceptor. So that one's hopefully quite an easy one that we've seen before. We can do that for pretty much any acid, but what we can also do is we can do it for bases. So if we have NH3 and we have water, so you've probably hopefully seen this before. We've got the ammonia, which we know is a base, or hopefully we know is a base. When they mix with water, we get ammonium, which is NH4 plus, and we get OH minus. So because it generates that OH minus, it's an alkali. So even though this doesn't contain OH minuses, when it's mixed with water, it does create OH minus. So that's why this is an alkali, even though it doesn't contain OH minus. So this is our proton acceptor. So that means this ammonia is the base. This time this is the H plus donor. So this time our water is acting as an acid. So when our water acts as an acid, our product is the OH minus, and when it acts as the base, the H plus acceptor, it turns into that oxonium ion. But whenever we're trying to find out or realise this, or identify rather, if something is an acid or base, all we have to do is see if it's got an H plus donor. So here it's got two H's, now it's got one, so it's donated one. We started with 3 here, now it's got 4, so it's accepted one. So that's a relatively standard one. But what we can also get is if we have two traditional acids, so if we have HNO3 and we have H2SO4, so we've got nitric acid and we've got sulfuric acid. So we would immediately think they're both acids, but if we mix them together, one is going to act like an acid and one is going to act like a base. So if we mix those together, we actually get HSO4 minus and we get H2NO3 plus. So this time we've gone from 1 proton to 2. So this is a proton acceptor. I can't spell acceptor. So this is our base, and this is our proton donor. So this is our acid. Right, what I want you to do is task 1 in the worksheets. Right.
I'm only laughing because I'm doing the same, talking to myself. I take it Kieran's not showing up today. Kieran Futural.
No.
He's not on there because he should be in.
Oh, he's not in.
Yeah, no, that I can see. Right, cool. Thank you. And Grace isn't either. So Grace and Kieran.
Grace can say no.
No, I know. So we need to send Kieran here as well. Both of them.
All
So both technically. Not gone yet.
Yeah. Oh,
Right.
Grace has messaged me. She said she's already been told.
Right, perfect, lovely, thank you.
Right. Any questions yet? Do task 1.